So today we're going to look at the State of AI report. And this is a report that was brought to us about a month ago. It was released. And we're just going to walk through it in kind of more careful detail today and try to get a deeper understanding of some of the topics and themes that it's addressing. So here's the State of AI report. Nathan and Ian are the main authors here. They're each kind of involved in both venture capital as well as helping AI with a bunch of different foundations and research and programs to help more of this stuff happen faster. So they've been following the space and publishing these reports for 5 years. So they're pretty credible, interested parties who have some history of interest here. And so they have a lot of network and a lot to contribute. So let's take a look. Artificial intelligence is a multidisciplinary field of science and engineering whose goal is to create intelligent machines. And they're sort of talking about the state of AI in this 5th year. So they look at 5 key dimensions. One is research. So what are the technology breakthroughs and capabilities? One is industry. What are the areas of commercial application for AI and the business impact? What are the politics of AI? So how does it work with regulation and economic implications and evolving geopolitics? They look at safety, so identifying and mitigating catastrophic risks, and they make some predictions. So one of the themes that they have done before and they continue to do now is that they're going to make predictions about previous years, and one of the first things we'll do when reviewing this, we're going to look at and score the predictions that they made from the previous sessions and see sort of how they score themselves on that. And then these are some of the research assistants who helped with that, with the preparation of this pretty substantial document. So first they start with a few definitions. I think generally we all have a common definition understanding of artificial intelligence. AGI, the generalized version of intelligence, is really about will machines be able to exceed human cognition abilities kind of across all economically valuable tasks. So not just centered around the aspects of artificial intelligence that may be very specific or vertical specific. Maybe we look today at something, like these, text to image generation or image to image generation, kind of generative video and AI stuff. Maybe we look at that and say, oh, that's really cool. But those are very kind of specific, kind of niche, narrow verticals that may have some broad applicability. But AGI is looking at sort of all economically valuable tasks. AI safety is studying and attempting to mitigate catastrophic risks. Machine learning is a subset of AI. So a lot of people talk about AI and ML fairly interchangeably. ML is actually the subset that uses statistical techniques to give machines the ability to learn from data without being given explicit instructions. So they talk about this as training a model using a learning algorithm that progressively improves model performance on a specific task. Reinforcement learning, this is an area we actually need to make a separate video about. There's a lot to look at here and discuss, but it's an area of ML in which software agents learn goal-oriented behavior by trial and error. So effectively set up a goal, set up a kind of a closed system with a set of activities you do leading towards that, and see if you can kind of figure out how to get better at that goal by just executing a bunch of kind of random walks within that closed system. And you get rewards and penalties based on response to the actions. That's called a policy. Deep learning is an area of ML that attempts to mimic the activities in layers of neurons in the brain to learn how to recognize complex patterns in data. So it's trying to take a specific form of ML, which would be understanding more about kind of neuronal composition and layers, and use that to try to represent data to get higher performance machine learning. Model, so definition of a model. Once an ML algorithm has been trained on data, the output of the process is known as the model. So models are kind of like the kind of the smarts, or the, if you want to think of it as like virtual thinking that goes into it. Those only happen when you train them. So you have to train them on a set of data, and usually it's a fairly large set of data to create a good model. And once you've trained it, then you can go to that prediction step. And the prediction step is the one that you're probably most familiar with if you've played with some of these tools, where you can provide something, some sort of input, and it provides some sort of, interesting or clever output. That's because it's making predictions based on stuff that it's been trained on. Example of this might be like, you've probably heard of GPT-3 or other large language models. Those are models that have crawled information on the internet, for the most part, uses a lot of text data on the internet, and is using a statistical model to figure out what is the next most likely word, or one of the next most likely words that you would see given the set of the previous sets of words that I looked at. So that's an example of a model. Self-supervised learning, form of unsupervised learning where manually labeled data is not needed. So the concept of labeling is something that you run into when you want to try to, something about the data, so you can create these labels, and these labels help train the model. But unsupervised learning or self-supervised learning, you don't need to do the labeling, so you don't need sort of humans involved in that step. Having humans involved in labeling, it means that you limit the scope of how big the data set can be, and you just sort of limit how fast you can do everything. So raw data is instead modified in an automated way to create artificial labels to learn from. Example of SSL is learning to complete text by masking random words in a sentence and trying to predict the missing ones. So imagine you give it a sentence, you mask one of the words, and now you want to try to figure out what is the word that was masked. And that's an example of a type of thing that can work pretty well. Large language models, LLM, these are the famous ones you hear about all the time today. This is things like GPT-3 as an example of this. There's a model trained on textual data. The most common use of LLM is text generation, and LLM is used to designate multi-billion parameter LLMs. But obviously, moving definition, this is constantly evolving, and as sort of, I think everybody's familiar with the GPT-3. Of course, GPT-4 comes, it has a lot more parameters. Presumably, it should be able to make better predictions, possibly with less input, to get better predictions of likely outputs that would be palatable or interesting to a human. Computer vision, enabling machines to analyze, understand, manipulate images and video. This is very common in areas like autonomous driving. So autonomous vehicles use a lot of computer vision as one of the main sensory inputs to understand positionally where other cars are on the road, and how you might want to, what kinds of information you might want to process based on those visuals that are sort of captured and understood. And Transformer is a model architecture at the core of most state-of-the-art ML research, composed of multiple attention layers, which learn which parts of the input data are the most important for a given task. Transformer started in language modeling, then expanded to computer vision, audio, and other modalities. And the Transformer paper was a very important kind of pivotal moment around AIs. And so we'll also do another video where we look deeper into that. So those are some of the basic definitions. Here's the executive summary of the State of AI report. So there's sort of those key areas, research, industry, politics, and safety. So in the research area, diffusion models took the computer vision world by storm with impressive text-to-image generation capabilities. If you're on the internet, if you're following any of the videos that I make, obviously you've seen those before. AI attacks more science problems, so ranging from plastics recycling, nuclear fusion, reactor control, and natural product discovery. Scaling laws refocus on data. Perhaps model scale is not all you need. Progress towards a single model to rule them all. Community-driven open sourcing of large models happens at breakneck speed, empowering collectives to compete with large labs. That's a very interesting trend. Reason being, too, is, the more that we have community-driven and open source stuff, the more that sort of everybody gets benefits from these technologies. These technologies have a lot of centralizing forces at play. And so if you want to limit the centralization, you want to limit the number of like corporations that are going to have monopolies on this. Instead, you want these to be more accessible to more people. More of the compute could be decentralized. The models could be decentralized. You'd want some of these these collectives to be able to work. And so that's an area of research. Inspired by neuroscience, AI research are starting to look like cognitive science in its approaches. Now, within industry, have upstart AI semiconductor startups made a dent versus NVIDIA? Usage statistics in AI research shows NVIDIA ahead by 20 to 100x. There are, NVIDIA makes most of the chips today that are used to run these big models. And there are some upstart AI semiconductor startups, but they're kind of, not far enough along to really be competitive. But they're, within range that they could make it. They could leapfrog, or they could at least meet. Big tech companies expand their AI clouds and form large partnerships with AGI startups. Hiring freezes and the disbanding of AI labs precipitates the formation of many new startups from giants, including DeepMind and OpenAI. And I think you see some of that stuff, especially with DeepMind. Inside a larger corporation, you have politics at play. You have maybe ESG, DEI initiatives. You have a lot of infrastructure and existing business to protect. And so there are a lot of different parties within a large org that compete to try to have their agendas furthered. And, sometimes with kind of a small focused group of individuals who doesn't have the organizational kind of baggage or process, and you could argue whether that's good or bad, but those are often the ones that are going to be able to build something newer faster because they just don't have the baggage. So it's interesting kind of at the time where there's layoffs and there's hiring freezes and disbanding of these, it actually, gives a lot of opportunity for new startups. Major AI drug discovery companies have 18 clinical assets, and the first CE mark is awarded for autonomous medical imaging diagnostics. So you can sort of look at these technologies and how they apply across many different categories, and obviously medical imaging and sort of drug discovery are important ones. Latest in AI for code research is quickly translated by big tech and startups into commercial developer tools. You already see the work that GPT-3 was a launch partner with OpenAI Codex, and you can see sort of how AI code generation works in a commercial developer tool with GitHub Copilot. So that's a good example of that. Politics. The chasm between academia and industry and large-scale AI work is potentially beyond repair. Almost 0% of work is done in academia. So, the industry, just because of probably compute resources and access to large data sets, probably can just accomplish a lot more than academia, and it would be good if there's some counterbalancing forces to that. I think most likely that's going to happen through things like open source and the collectives that we mentioned before. Great reshoring of American semiconductors capabilities is kicked off in earnest, but geopolitics tension is very high. This is kind of the U.S.-China relations and sort of how semiconductors work and sort of manufacture, kind of the importance of NVIDIA and ARM and how the interplay is between those two. AI continues to be infused into a greater number of defense product categories, and defense AI startups receive even more funding. So obviously, defense has huge budgets. It is always sort of, an arms race in the most literal sense. And so, when there's defense at play, there's lots of budget available. And so it's a good way for these initiatives to be pushed forward with more funding that is not always going to be fully corporate. AI safety research is seeing increased awareness, talent, and funding, but is still far behind that of capabilities research. So that's what we've got for the executive summary. And now we're going to look at the predictions from 2021. So they were going through and reviewing the predictions from 2021. Here's the 2021 predictions they made, and then they gave themselves grades and they gave evidence. So 2021 prediction, they said transformers replace recurrent neural networks to learn world models with which reinforcement learning agents surpass human performance in large and rich games. They graded themselves yes. The evidence is DeepMind's Gato model makes progress in the direction in which a transformer predicts the next state and action, but is not trained with reinforcement learning. University of Geneva's GPT-like transformer model, Iris, solves tasks in Atari environments. And Atari is an the Atari games and playing Atari games with reinforcement learning is kind of one of the early reinforcement learning examples that's often given. 2021 prediction: ASML's market cap reaches 500 billion. They got a no. The current market cap is about 165 billion. Who knows if that's due to the market, overall kind of market negativity and sentiment, or if there was something specific that they missed. My guess is the general market had a lot to do with that. Anthropic publishes on the level of GPT, Dota, AlphaGo to establish itself as a third pole of AGI research. Grade is no. The evidence is not yet, so it sounds like they're still optimistic on it. I've heard a lot of buzz about Anthropic. Obviously had a huge funding round, and there's a lot of good AI talent flocking there. Could be kind of a credible contender to some of the stuff that OpenAI is doing or Stability AI. So they're another kind of research-focused org that could have a lot of like platform characteristics to it. A wave of consolidation in AI semiconductors, with at least one of GraphCore, Cerebras, Samba Nova, Grok, or Mythic being acquired by a large technology company or major semiconductor incumbent. And the answer is no new announced AI semiconductor consolidation happened yet, so they graded themselves a no on that. Small transformers and CNN hybrid models match current SOTA on ImageNet top 1 accuracy with 10x fewer parameters. They got a yes on that, and they said max VIT from Google with 475 parameters almost matched CoatNet 7's performance on ImageNet top 1 accuracy. I would have to read more about that to try to assess how the score and evidence work there. But I think they're being very reasonable about sort of how they're rating their assessments here. DeepMind shows a major breakthrough in physical sciences. They graded themselves a yes. There were 3 DeepMind papers in mathematics and material science. The JAX framework grows from 1 to 5% of monthly repos created as measured by papers with code. And they graded themselves a no because JAX usage still accounts for less than 1% of monthly repos on papers with code. And a new AGI-focused research company is formed with significant backing and a roadmap that's focused on a sector vertical, example, developer tools, life science. And they graded a yes on that because Adept.ai was co-founded by the authors of The Transformer and is focused on AGI via software tool use automation, which I think is a good example of how, the modern interface to the digital world is the web browser. And so Adept.ai has models that can interact with the web, with a web browser, kind of keyboard and mouse as is, and can attempt to use that to learn about the world, to interact with the digital world, learn about the digital world, and try to make productive use of that knowledge and data set and information category.